My dear students, we will look into lecture 9 of module 4. Now we are trying to design binary to BCD converter. So in this converter, our objective is to design. So for this design, what we require is we need to develop a truth table in step 1. In step 2, we try to write the expressions for output in terms of inputs, because outputs are functions of inputs. Then we derive expression for outputs in terms of inputs in a simplified form using K-maps. Then we write the expressions from the K-maps. From the expressions, we draw the circuit. Once we get the circuit, the design is complete. So now we will look into the step 1. In step 1, that is a truth table which will give the input output relations. The input is binary, output is BCD. BCD stands for binary coded decimal. Binary input. Binary inputs that we are trying to give is 4 zeros to 4 ones, all possible combinations. 4 zeros to 4 ones, which is 2 power 4 combinations. 2 power 4 combinations are 16 combinations. So the 2 power 4, which is 16 possible combinations. Those 16 possible combinations are listed over here, which is nothing but 0, 0, 0, 0, 0, 1, 0, 1, 0, means 0, 0, 1, 0, 0, 0, 1, 1, so on and so forth till 1, 1, 1. So for this input, we have to get a BCD. But in BCD, if at all you look for, you'll get from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we start with 1, 0. So to represent 1, 0, to represent 0, I need 4 bits, and to represent 1, 1 bit. So 5 bit. That is the reason why output is 5 bit. It starts with A, B, C, D, and E. So up to 9, I mean to say 0 to 9. Okay. BCD is also equivalent to binary. But once your binary goes beyond 9, in BCD we need 2 digits to represent. So this is 1 followed by this 4 zeros represents 0, 1, 0. This 1 followed by 1 represents 1, 1. 1 followed by 2 represents 1, 2, 1, 3, 1, 4, 1, 5. So we need a 5 bit code. That is the reason why input is a 4 bit code, output is a 5 bit code. So we need 5 K maps, okay, to get the solutions for 5 output variables. Number of K maps required is nothing but number of outputs. So here our number of outputs, how many number of outputs I have? The number of outputs I have are 5. So we are going to use 5 K maps. What is the size of the K map? Size of the K map depends on number of inputs. So 4 variable K map we are going to use. How many? 5. From that, what I am trying to get is expression for A, B, C, D in a simplified form. So we will be looking at them individually, one after the other. So here you can see here. So X, Y, Z, T are the inputs, binary inputs. This is the BCD output. For very first case, okay, it is 1 for, so in the step 2, what is step 2? What is step 2 says? Step 2 is one where we are trying to write expression for output in terms of input. What is output? A. So what it is? Which is a function of, what are the inputs? X comma, Y comma, Z comma, T. This is what exactly the thing. Next, what I want? A, which is in terms of min terms. Which min terms are there? For which it is 1? For 10 it is 1, right? For 11 it is 1. Okay. For 12, 13, 14 and 15. So can I write it as 10, 11, 12, 13, 14 and 15. Is there any don't get terms? No, don't get terms. So as we know, this is 0, 1, 3, 2, 4, right? 5, 7, 6, okay, 8, 9, 11, 10, 12, 13, 15, 14, right? So it is 1 for 10, 1 for 11, 1 for 12, 13, 14. So can I combine this 4? Yes, for sure. What is that? It is xy. Why? There is no z and t, because here if I look in, here z is changing and t is changing. So if I come from here to here, t is changing. If I go from here to here, t is changing. Anything that is changing will lose. What is the meaning of that? The meaning of that is it is z plus z bar, or it is t plus t bar. What is z plus z bar is 1. What is t plus t bar is 1. That is the reason why the one which is changing will not come into the picture, because this all in this row our z and t are changing, only x and y is fixed, no changing. So it is expression for this is x1. What about this 4? Can I combine this 4? For sure I can. So what is the expression for this? If at all you look for, if you look for here, what is constant? Here this is 1 and this is also 1. What is that? That is z. So write z. And what about this in this 2? 1 0 changing. So it will not come into the picture, which is under y. So y gone. So x is there. So it is xz. What is the expression? The expression for what is the expression for a is nothing but what is a? A is output. So a is nothing but xy plus xz, xy plus xz. This is the expression that I am going to get it. So now let us look into the other outputs b and c. So what if you look at the b, what is the b if at all it is there is for 8, 9, 10, 11. So for b you should see the expression, for c you should see the expression, then we can write. So in the under step 2 what I can do is expression. So it is not 8, 9, 10, see here 8, 9, likewise up to where exactly 8, 9, 10, 11, 12, 13, 14, 15. So 8, 9, 12, 8, 9, 10, 11. This is 10, this is 11, 12, 13, 14, 15. Anything more it is 1. Output B. Output B is 1 only for these things. So can I make them as a group? Yes, of course we can make them as a group. So what is this expression? B is nothing but, how exactly B is? So if you see the B part, is it not X? Yes, it is X, got X. The same as X. Next C part. If you see C, it is 1 for 4, 5, 6, 7. This is 4, 5, 6, 7. Then any more time it is 1? No. Oh yes, it is 1 for 14 and 15. So this is 14, this is 14, this is 15. This is 8, 9. So you know numbering right? 0, 1, 3, 2, right? 4, 5, 7, 6, 8, 9, 11, 10, okay, 12, 13, 15, 14. So with this what exactly that we got it is, can I combine this 4? For sure yes. Can I combine this 4? For sure yes. So when I combine this, is it not x bar y? Yes, it is x bar y. When I combine these two, what is their common? Y. What is their common here? Here it is z. So it is yz. For this expression is yz. For this x bar. So the overall expression for C is nothing but x bar y plus yz. What about this one? It is nothing but simply x. Now let us look at the D part, that is output D. Then we will look at output E. So in D, if at all you see here, for 2 and 3, where is 2? This is 2, this is 3. Then for 6 and 7, so this is 7, this is 6. Then it is 1 for 12 and 13. Where is 12 and 13? This is 12, this is 13. So anything more? No more. Totally 6 ones. So this 4 ones you can combine. These 2 ones you can combine. Is there any don't care terms? No more don't care terms. So no more possibility. This is only the possibility. What is the expression for this? If you want to write the expression for this, and try to write the expression for this. So what is the expression for this, if at all you look for, is xy. In this, what is common is here t is changing. See, from here to here t is changing, so no more t. Z is 0, so z bar plus this expression. What expression that I am getting over here is, if at all I look for, what is common here is x bar. What is common here is z. So x bar z plus x bar z. Okay. So similarly, I can look for E. So if I look for E, what are the values of E? So for 1 it is 1. Okay. For 3 it is 1. So for 3 it is 1. Then for 5 it is 1. So 4, 5. For 5 it is 1. Then for 7 it is 1. Then for 9 it is 1. So where exactly 9? 9 is here. For 9, for after the 9, 11 it is 1. So 11 it is 1. Then it is for 13 it is 1. So it is for 13 it is 1. For 15 it is 1. 15 it is 1. Anything more? No, nothing. So what I can do? I can combine like this. Okay. So what is that it is? Is it not T? Yes, it is T. So I got E equal to T. D equal to what I got? XYZ bar, X bar Z. So D is XYZ bar plus X bar Z. What exactly A I got it? What exactly? B is X. I got B as X. Right? What exactly C I got it? C is X bar Y, YZ. C is X bar Y, X bar Y plus YZ. What is A? I got it. A I got it as, if at all you look back, A I got it as XY plus XZ. So A is XY, this is XY plus XZ. So with these expressions, okay, so what I can do? I can draw the diagram. Say XY, you take X, Y, connect it to AND gate, right? One of the input is X, another input is Y. Next XZ, you take another AND gate, one is X, another one is Z. Then what you need to do? You need to connect them into OR gate. What that will give you? If you connect it to the OR gate, we will get A. Next B. What is B? So this B is directly from X. No such circuitry required. C. What is C is, I'll take X bar, then I'll take Y. So X bar Y. This is Y. I'll connect it to AND gate. How do you get X from X bar? You take X, give it to the inverter, then you will get X bar. If you want Y bar, you will give it to the inverter, you will get Y bar. If you want Z bar, okay, from Z. So I will take Z, give it to the inverter, you will get Z bar. If you want T bar, connect to the inverter, you will get a T bar. So I am assuming that X bar is available. That means I need to show one. If I write X, I need to show one inverter over there. Either way, it is possible. So what I need to do is further X bar C part, X bar Y, then YZ. So X bar Y, then YZ. So you take Y, you take Y, you take Z, give it to the AND gate, then you OR them, you just OR them. Once you OR them, then what exactly that I am going to get is C. Next, what we try to do is XYZ bar, X bar Z. E is T. So further, we want E, just from T I will get it. So for D, we need XYZ bar, XYZ bar. So XYZ bar, XYZ bar. Give it to AND gate. Then what I want? X bar Z. So I take X bar, then I take Z. I will give it to the AND gate. Both of them I will give it to the OR gate. Okay. So I will connect them together. Then I say D. So I got all A, B, C, D, E. What is this converter circuit? This is from binary to BCD code converter. I hope it's clear. So this is how one can convert it. So this is all about the binary to BCD converter. What is the takeaway? Overall takeaway is circuit is developed or built or designed, right?